Hi, Assalamualaikum. Welcome to our video.
My name is Nurlili Amira binti Muhammad Rashid.
And my name is Intan Nu'aim binti Nazli.
Our project is Indoor Air Quality Monitoring System. So for our project background, indoor air quality has always been a matter of concern for the international scientific community. Based on the concentration values detected on a study that was conducted, the conclusion of the paper indicates that depending on the technological process or activity in enclosed spaces, it is mandatory to check the indoor air quality. This action must be taken as prevention in order to reduce potential health risks upon humans acting in their homes or schools and offices or industrial halls. Repeated exposure to pollutants in indoor environments is reported as one of the potential causes of several chronic health problems such as lung cancer, cardiovascular disease, and respiratory infections.
Next is objective of project. For the first is to monitor level of air quality in room. And second is to develop a low-cost device for IAQ monitoring. And the last is to design an innovative air quality monitoring system using IoT system.
Problem statement for our project is discomfort of students, such as experiencing frequent coughing, sneezing, and headache in confined places, which can indicate unhealthy air quality. The second is students experiencing sick building syndrome, or also known as SBS, which may be caused by the age of the building. And the last problem statement is dusty or poor ventilated room or any confined spaces.
Next is scope and limitation. This project used an MQ135 air quality sensor for the environment. The IoT system used for this project is Blink application, and the sensor can detect NH3, NOx, alcohol, benzene, and smoke. Next is literature review 1. Poor indoor air quality can be particularly harmful to vulnerable groups such as children, the elderly, and those with cardiovascular and chronic disease such as asthma. Household air pollution is one of the leading causes of disease and premature death in the developing world.
For literature review number 2, the study indicates that indoor air pollution, which is IAP, is a leading environmental risk closely related to the health, comfort, and well-being of building occupants. As people spend 90% of their time indoors, repeated exposure to indoor air pollutants affects people's working performance and productivity levels. Literature review number 3, the study aimed to determine the association between indoor air quality and the prevalence of sick building syndrome, which is SBS, among office workers in new and old buildings in University Putra Malaysia, Sedang. The SBS symptoms were assessed by using the questionnaires of Indoor Air Quality and Work Environment Symptoms Survey, NIOSH Indoor Environment Quality Survey 1991, while for the IAQ and IAP, they were monitored by using the instruments used for this study. For this literature review, it tells us how a study was conducted to find out the air quality in a room in 3 different settings, which is for seasons, ventilation, and also the temperature of the room. And they found out that all of them have different air quality results.
Review 5. The prototype of the air quality monitoring system used for research has been developed and works well. The system is based on IoT, where dust and temperature monitoring can be done remotely using a smartphone connected to the internet through the website address. The greater the dust density, the greater voltage required. Next is material and method. We have ESP32. It collects data from MQ135 air quality sensor, process data before transmitting to the output, transfer data using Wi-Fi protocol. Next is LCD display. Display value and status of air quality. Can easily observe the condition of air quality. Next is MQ135. Has a high sensitivity to ammonia, sulfides, and benzene-based vapors, and is ideal for monitoring smoke and other harmful gases. Low-cost sensor suitable for a variety of applications. Next is cost benefits analysis. The component that we use is ESP32, LCD display, MQ135, LED, red and green, and also PVC box. So the total cost is 59 ringgit 20 cents.
Okay, so this is our block diagram. So what we have here is we have our sensor MQ135. The sensor will detect the air quality in our surrounding air, and then it will transmit the value to ESP32 where it will receive the value and will send outputs to LED. If it's good, the green LED will light up, but if the air quality is bad, the red LED will light up. Then it will display the value and status on the LCD display, and will also display the value on blink and send warning if the air quality is too dangerous for the people around in the room. So this is our flowchart. The process will start with when the MQ135 sensor detects the IAQ level, and then it will check if the IAQ level is less or the same as 200, then the green LED will light up. The LCD will display good and also the value, and the value of the IAQ level will also be displayed in the blink application. Next, it will check if the IAQ is larger than 201 or the same as 201, then the red LED will light up. The LCD display will display danger. Blink display will also display the level of the air quality, and then it will send out a notification to warn the people that the air quality is bad. And then after that, it will end.
So next is, this is our project sketching. The first picture is back view, and the second is front view, and the last is fully assembled part. Okay, next is testing and experiment. MQ135 sensor. The sensor is tested using various gas. For example, is benzene, smoke, and isopropyl alcohol. The second is LCD display. Value and status of air quality will be displayed here. And the last is blink. Blink application will display the current air quality value and send out a warning when it has exceeded the set value.
So this is the result that we got from testing benzene using the MQ135 sensor. For the first attempt, we got 656 ppm. The second attempt is 1456, and the third attempt is 1778. All of these values will trigger the blink application to give out a warning to the user. The next is using testing using isopropyl alcohol. The first attempt, we got 1651, which will trigger the warning. Second attempt is 1574, also will trigger the warning, and third attempt is 682. The result will also trigger the warning in the blink application. This is testing smoke. For smoke, the first attempt is 50, second attempt is 25, third attempt is 12. All of this in which the range is still safe for the people in the room. And this is our alarm system. The blink application will send out a warning and tell that the air is polluted and it is a low level of air quality. And this is our project demonstration.
In conclusion, by using the MQ135 air quality sensor, it can provide us with the values of the current air quality in any confined space with warnings when it has entered a dangerous level, thus improving air quality by alerting the people around using the warning notification from blink to prevent the air quality from worsening. Overall, this device has the potential to revolutionize air quality monitoring system while promoting safety and health. That's all from us. Thank you so much. Bye.
Bye.